Hey guys, so in this video I'll be telling you how I'll be handling missing values in the data set, and also how to concatenate two data sets which have uh, common values using merging, join or concat like that, and what will happen if while concatenation, while giving inner or outer, um, like that, or full join, like this kind of join methods or cross join, if there is any possibility to lose the data. So I'll be explaining that now in this video. So this notebook is a part of CommonLit Evaluation Student Summaries Competition, which is happening on Kaggle. And you can, like, if you find this missing values video very doubtful, or if you have a lot of doubts and not able to understand how to handle missing values or the outputs, then you can check out my last video where I have explained taking simple data frames instead of competition data frames. I have explained how are missing values handled. That video also I have made. So I'm trying to take st.copy. St is a basically, you see, it is a summaries data. This kind of data is summaries data and prompts data set. We have two data sets here. So st data set is that one, and you can see I'm trying to merge two data sets, that is the prompts data set and the summaries data set, on one single column that was common between them, that is prompt ID. And we see that one thing here is on the outer join, it does not drop off several NaN values, and we have lot of data which is present in the M, that is a summaries, but um, the prompt question, prompt text is not present here, and the data columns are also 7,000 plus, and we have less to zero null values, and even NaN values are like that. So I have not specified inner join or left outer join or r suffix or index values, since it will drop off the uh, data, and we might have missing data. Like in inner join, when you join, then you have common columns which are present between those two data frames are taken out. In left join, you have more of left data, and data which is common between both of them in the right table, they are taken. Similarly in the right join as well. And if I give you on particular column name, then whatever is matching, it will take, and whatever is not matching, or whatever has NaN values or null values, those are dropped off. And we have only 7,000 entries, and if I use on, I have tried to use on, but here prompt ID, but we do not have data from the prompt side. We have some missing data, like prompt should have had something like this: prompt question, prompt title, prompt text, but it's not there. So you can join this data using a common field. Wait a minute, I'm actually trying to see where is that, where did I go? Yeah, M. ikkadne undanu. M dot is null, we have zeros, so there should be another method to concatenate or merge these two data frames. So I've tried to concatenate them, and we have 8 columns. I guess something that's bigger than last one. 1 2 3 4 5 5 ఈ మూడు వచ్చేసినాయి ఇప్పుడు. You see 7165 entries, but wording has less, it's 4. So basically in the first we had prompt question and prompt title, prompt text. Prompts dataset was smaller than the students dataset. While concatenating, we see that student ID and prompt ID values actually became 0. Prompt ID should have been there, but it is 0. And am I seeing for the right data set? Yeah, but it is there for prompt ID. Okay, sorry, I was seeing the null values. I actually thought it was the data frame entries, the count of data frame entries. I'm sorry, that was my bad. So the null values which are present are 7165 and 7165. So basically, in prompt database there are only 4 entries, and I was seeing from where did 7165 entries come. So there are 71. While merging, we had greater size for this one summaries dataset over here. That's why it was coming as 7165. Okay, and include only rows where any one column has a null value. So I'm trying to use like different kind of grouping methods to show you how can we find the null values. So using any access is equal to 1. Access is where to access the columns, and we are trying to see if there is any null values. We have null values in prompt text, prompt question, and also where in the student ID. And we can fill the null values in the content using mean, because content and wording has are numeric type, so we can fill by mean or more frequent values. And we also have categorical data where, which is of object type. Like we have 6 object types here, so we can fill categorical data using simple imputers, or by replacing with manual values, or by using pipelines. sklearn pipelines are very efficient. You can also use that, but I have not used pipeline as this because I wanted to demonstrate in this video. And I'm filling it the wording values. This is an integer type, so I'm filling it with 0. And if you see, the null for the wording is the sum count for null values is 0. I'm trying to also demonstrate the simple imputer. For the I'm copying this data set C into a temporary data frame, and when you apply it with most frequent value, then usually it displays you array. And I'm not applying these functions directly on the temp underscore df, but this is just printing it out because I wanted to demonstrate. So most frequent value is whatever frequent value appears in every column, like the mode. So like the imputer tries to replace it with the most frequent value for every column. And you can see an n-dimensional array. The type of it is also array. So for handling like operations in sklearn or scikit-learn, then usually it gives you an nd array or n-dimensional array, so big and nice. And strategy is constant. So these are different kinds of strategies. So we take constant values and fill it with any value, like missing or unknown or to be known, or unknown find, like find value, like that. While filling categorical data, like categorical data is like string kind of data, like see missing like that, missing. So this is temporary data frame printout. We are not doing changes in our in our C data set, our original data set. So I'm just showing this. And suppose if we have np.nan, that is nan values, and instead of fill na, we can use a constant strategy, and we can fill the value using missing. So on the complete data set, it will be loaded. And this is how our temporary df looks like. And suppose if I want to make changes here, then temporary df of text dot fill na missing, like I'm filling wherever there is not a number, we are filling it with a missing value. And temp df dot fill na of unknown, in place is equal to true. Okay, sometimes if we suppose if we don't give you in place is equal to true, then it will just print it out and it will not replace in the original tempdf data frame. So that's the reason I have given a parameter like in the method in place is equal to true. And for content also we are replacing it with unknown. I have actually done a mistake here. Can you point out the mistake? 2 seconds. 1 2. If any can point out the mistake. So content is basically a float type of data type, but had to replace with a float or integer. It will be have been very easier if we do that, or with mean or mode or median, but it replaced with unknown, a string, which is not correct, because while data analysis, if we do it, then it will become we have to replace again. So I did that mistake here. So you see the data frame dot head. Again I'm trying to see if unknown is present throughout the data frame, and yeah, it is present here. So let's explore the data. um, After cleaning the data set, I wanted to see if the changes have been made, because I have given in place it is equal to true for some of the methods here. So I'm copying this data frame into another data frame E. So E of wording dot mean and E of content mean, I have taken it as average wording score and average content score, because obviously our goal is to predict the scores of word and content in this competition. With I'm not using any machine learning libraries here, as I told you previously in my last video. So I'll be using this numpy and pandas for predicting the score and for creating a special feature in the end. So using that particular boolean value or text, I'll be doing predictive data modeling. And so E of wording, so because we have the average score, and I wanted to see if there is any wording, any of the students who scored exceptionally very high and is a good student, very very bright student, if they had greater than the average score. So based on those average score, I got the student IDs over here, and there are some unknown values here as well, because it's a concatenated data frame. And what was the average content score? So we have our average wording score and average for these students, what was their content score. So for the exceptionally bright students, the content score for the first target was 0.56. And so I thought, why not we create a filter and add it into the data frame, into this particular final data frame. So I thought, if the content score of the exceptionally bright students was 0.56, then let's create an edge mark over here and keep someone who's above 0.56 has good, and someone who's below 0.5 has not bad but okay. Yeah, they made their mark there, and at least they tried, they did not give up. So we are concatenating a column named pass, where and also we have content here, so content dot mean. So if it is greater than equal to 0.56, then it is good, and I'm renaming it as pass and adding it into the data frame. In the final data frame E, I wanted to also see how many of the students are have passed and how many have failed. So the failed students are 5520 and the passed students are 1649. I should have decreased the score, yeah. 50 is too high for passing score. Should have at least made it 30 now, because in BTech exams we have it as 25 in our college. Good olden days. And E dot sort values, pass. So this is my end value. So usually you sort it and you give a good impression to someone. So first we have true values, like everyone passed in this, and later we have in the end false values. So that was about missing values and how to do data cleaning, pre-processing. So in this one we have the last column as pass, right? So using this just one column and giving this data frame, temporary data frame in AutoML or Azure, and Google prediction libraries, then or Azure SageMaker, no, AWS SageMaker, um, that can give you predict the content score and word score. And yeah, if these prediction logs are submitted in this competition, then there are chances that I might get greater upvotes in Kaggle competition. Yes! Nako, if I win this competition, then yeah, that would be a party. Celebration time. Hmm. And what else? If you like my video and if you like the hard work which I put into this notebook, then you can give me an upvote here and you can leave the comments in YouTube if you want to see, uh, if you want any particular prediction notebooks like for cloud environment, Azure or GCP or SageMaker, AWS. I'm not a AWS fan, but I have used Azure and GCP in Kaggle notebooks. So, cheers! Ta-ta! Bye-bye! So let's stop the video here.